I'm going to talk to you about REST and what REST architecture means for us as web developers. So REST stands for Representational State Transfer. It seems like maybe a bit long. You might want to look it up on Wikipedia, find a definition. You would discover this long, pretty cryptic definition here. So then you might look into it further and discover that there are actually 6 constraints and a few architectural approaches that are part of the REST philosophy. And then while doing that, you'd realize that there's a lot of vocabulary, and you would probably get pretty confused by now. So I have a radical idea. In exploring all of this, I've come to the conclusion that the point of REST is simplicity. The reason we as web developers want to use REST is to provide code that is easy to use, both for people and for programs. So hopefully by the end of this presentation, you'll agree with me on that. To start out, here's a couple of pieces of vocabulary. We're going to talk a lot about resources and states. Resource is just a component on the server. In our case, as web developers, we're most concerned with files that we're going to be sending back and forth between the server and the client. And then state is just sort of a snapshot in time of the information and properties of a resource. So let's talk about these 6 constraints. I'm going to walk through them one by one. Here they are, listed out. The last one is optional. And I'm just going to kind of explain what each of these mean for us as web developers. So when we talk about the client-server model, what we're really talking about is the idea that you have a client and a server, and that those two things are separate from each other. They are 2 separate machines, if you will, and that those things are connected by some sort of interface. In our case as web developers, that interface is going to be HTTP. What this really means is that outside of the request-response cycle, the client and the server don't care about each other's existence. When you go to google.com, google.com doesn't know you exist until you enter google.com into your machine and you try to go there with your browser. So this is what stateless is really all about. When we talk about stateless, we don't mean that there is no state. There is still state. Your application does have state. The thing is that the state is transferred. It's not shared between the client and the server. So we still actually have the concept of state, but the state exists on one side or the other of that boundary because these 2 things are separate from each other. So the client might have cookies or local storage that contains information that maintains the client-side state, and the server side might have its own state, but those 2 states can only communicate through a transfer of information via that uniform interface we talked about before, which is HTTP. And there are actually 4 sub-constraints of the uniform interface. The first one is one that we're all pretty used to by now. It's identification of the resource, which basically is the URL. You need to have some place where you can go to retrieve that resource reliably. If you go to /book, you're going to get book. You're not going to get a chapter, right? We also want to be able to manipulate the resources through some sort of representation of the resource. This is pretty important. This has to do with security and separation of concerns. So we don't want the client to be able to directly impact the database. They make a request to the server, and the server has an interface with the database itself. The uniform interface also requires a certain aspect of self-descriptive nature. So when you send an HTTP request, all the information about that request is in the request itself. That's what we talk about when we talk about HTTP headers, metadata. We're really providing information so that that request can exist on its own, right? And that when a client makes a request, the server can respond to that request in full. And then this last one is a lovely acronym, HADIOS, that basically what that means is that as a client, you don't know what interfaces are available unless the server tells you, right? You don't know that my website has a /about page until you go to my website and you see in the code that there is a /about somewhere in there, an href of some sort. So that's just the concept of like how are we connecting different pieces of our API or a service. And then we can also get into this layered system, but we don't really have to think about it. That's kind of the beauty of it, because the layered system means that we can separate out our concerns and just talk about HTTP. We know that somehow these things are traveling over the wire. We don't care how, right? All we have to do is think about HTTP and what information are we sending. We don't have to worry about how that information is being communicated. Another aspect is cacheable. So this constraint just means that you can cache the resources on the client side to prevent unnecessary additional data transfers. This is to make everything move faster, to reduce CPU usage on both sides. And then the last one is the optional code on demand, which is just that you can send code, right? When we're talking about a RESTful API, we're not sending code. We're sending JSON, maybe XML. But when we send a website, we might want to send some client-side JavaScript that's going to execute on the server. This allows us to extend the functionality of the application without the user having to download anything. So let's sum this up in a way that's really nice and easy to remember. Let's talk about representational. So representational means we have a representation of a resource, probably JSON in our case when we're working with a web API. There's no direct interface, right? That's what the point of the representation is. And this has to do with security. We have state. We have a resource that has some state at a given point in time. That state exists on the server, and we want to interact with it somehow. How? By transferring the state over a network using HTTP to create a request-response cycle. So hopefully, this talk has made RESTful APIs and RESTful architecture feel a little more approachable. And if you want to look into it more, here are some great resources that you can take a look at. Roy Fielding's dissertation was what actually defined what REST is, and I definitely recommend checking that out. There are a number of tutorials, and then here are also a few O'Reilly books that you can take a look at. I especially recommend the RESTful Web APIs book. That one's really useful. And the cookbook also provides some really great examples for things that you can get started making using the RESTful architecture. And thank you.